All right. Early. What's up, minion? Is my voice working in the Discord? I hope it is. I'm sure it's working on Twitch. I can see it's working on Twitch. Discord's always my question. Cause they screw stuff up. You ain't first. You ain't first, you're last. Yeah, well, you know, happens. Oh, okay. Okay. All right, let's see. A lot of screenshots today. That's good. Okay, very cool. Love this. Again, another part maybe. Yeah, okay. Yeah, wow. How do y'all post your questions so early? I mean, they just post them early in the day. So you can post it the day of. So some of them, I mean, Bob posted his, I think, at like midnight or something. Or Bob, wait, did Bob take his down? I forget where he put it. Oh, nice. And I was asking Bob. He's like, "Oh, I got work." He's like, "I tutor elementary, middle school is in math." Man of my own heart. That's dope.
That's dope.
Maybe you too can have a stream one day. What's up, Nick? Muggy says, "What if I said I like silver more than gold?" I mean, it's okay. There's nothing wrong with being second place. But, yeah, it's all good. Wait, where did... I thought Bob posted his question somewhere. Maybe he deleted it. Jamarcus. Nice. Yes. All right, let's see. Yo, yesterday's stream was nuts, by the way. I know we had a lot of first-time viewers who had just joined the Discord and stuff. Where's my, like... Where's not my stream manager? Where's my analytics, dude? This is it. Stream summary? Yeah, what was it here? Here it was. Yeah, these were our stats, dude. They were nuts. So, yesterday's stream, we had 3 hours and 15 minutes.
That's dope.
I think it's a record. I think that's the longest I've ever streamed is 3 hours and 15 minutes. Yeah, 2 hours and 47 minutes was the stream before that. We averaged 15 viewers, which is a lot. That's good. 22 max views and 63 unique viewers. Wow.
That's dope.
It's a lot. Yeah, a lot of things. Live views, great, sweet, more followers. Love all this. This is really cool. It's really cool to see everyone this is the chat history and stuff. A lot of followers. Oh, some people found us on search. That's cool. Yeah, okay, cool. Yeah, time is valuable, guys. Don't waste it. Yeah. Well, I mean, we had a lot of I think a lot of people wanted to like ask their first question for the week, which is cool. Totally cool. So yeah, if you're in the tournament and you asked a question this week, great. Good job. You got your 2,000 for the week. You can still get as many bond coins as you want during the week. Well, at least one per day. But yeah, if you're wondering about the tournament points and you asked your question, you're good. Let's see. Any other things happening in the server? Any other things I gotta take care of? Okay, cool. Yeah, that's all good. Yeah, wrong channel there. Cool. Okay. Did someone seriously just go and randomly thinking to search up actual education, discovering gold, giving up gift cards. I mean, sometimes if you go to what is it, the Twitch, you just go to like twitch.com or twitch.tv, sorry. It's not twitch.com, is it? And then you go to, for instance, what can we go to? You can just go to browse, and if you go here to like science and technology, you'll see all the different streams that are happening. So maybe they saw us. I think we're probably somewhere around here. Yeah, see, there we are, right here. And as you have more viewers and more time, yeah, you get put like higher up. So yeah, this is cool. Some guys like learning how to hack. This guy definitely looks like a hacker. White belt to blue belt education. Okay, cool. So he's learning. Yeah, you could teach some Python stuff. This is kind of cool. And then I guess what someone's looking for VHS tapes or something. Oh, it's an ad. I don't really want the ad. Okay, whatever. Yeah, man, you want to come seek? I have a bit of a cough today. You're doing Unity. That's cool. Unity's dope. It's a good language. Wasn't a lot of Fortnite built on Unity originally, I think? And then they moved over to Unreal, I'm pretty sure. The good gaming engines. Yeah, that's what I thought it was. Okay. Cool. Any other quick questions, comments, concerns before we hop into doing homework problems? Y'all let me know. What happened to the kid? Did you ban him? Yeah, I did eventually have to ban him. Like, I'll give students a lot of chances to like not screw up, but when you start spamming the N-word in my Discord, like, and I tell you not to.
Wait, what?
I warn you not to. Like, yeah, you're gonna get banned. Oh,
Wait,
just
what happened?
just we just had a troll. We're always gonna have. There's always gonna be trolls in the Discord. It's okay. It happens. Oh wow, this is a lot. Okay. Okay. First question. Well, here let's start the stream. All right. Welcome everyone. Office hours. My name is Dr. Gold. This is Actual Education. The stream helps you out with math homework, science homework,
Nice.
all types of work
Oh,
and learning stuff. What's up, Minion? How's your day going, dude? What's up with Tuesday?
good, I guess.
Good. That's
I
cool.
won the photo contest thing.
You won the photo contest.
That's dope.
Oh, was that your picture of the dog? You had a picture of a dog or something you won, right?
Yeah.
Oh, that's sick, dude. Nice. Congrats. I'm glad you beat out the picture of like a flower and like something else I saw, right?
There's a leaf, but yeah.
Yeah. Jamarcus says, does anyone else use those fake hacker websites? What are the fake hacker websites? Yeah, don't be careful clicking links. I gave out I gave out $20 in Robux to someone in the Discord, and they told me like the next day that they lost all the Robux because they clicked like a private link for a Blox Fruit server, and the guy just like took over their account and spent all the Robux.
That happened to me when I was like 7.
Yeah, right? Yeah, I feel like it happens to you. It'll happen to you once, and then you'll learn to not do that. I always say, like, don't click links. He's like, oh, it looked like a real server and everything, and then, like, they took all my stuff. Yeah. Oh, hacker types where you hit random keys, but it looks like you're hacking. That's too funny. That's why I don't play Roblox. I just don't know, like, what are you going to do with the Robux?
You
Like,
play Roblox? What?
I mean, I like Roblox. Yeah, Nick is saying that's why he doesn't play Roblox. I play Roblox. Yeah,
Oh.
Roblox is okay. But I'm confused. Like, why would someone just steal Robux? What are you gonna do with them? Like, you can't really buy anything else except Roblox stuff. You know? Can you resell Robux? Could you like sell it on the black market to people?
Oh, yeah. And if you make like games and stuff, if you're like a creator on Roblox, you can sell Robux. And Roblox will pay you.
Oh, Roblox will pay you. Oh, I see. So
Yeah.
they steal the Robux and then they spend the Robux probably on like their friend's game or something, and then they get paid out. Is that how that works?
Basically.
Oh, okay. That makes sense. What's up, Tico? Nice. Okay, let's see. Is not your friend here? Not your friend. You have your first question of the day. Where is not your friend? Here, let me tag him. Tag him at not your friend. Not your friend's not online. Unless not
His
you.
name is actually not your friend.
Yeah, his name it is, dude. His name is not your friend on Discord. I guess I could look up what his Twitch name is.
I thought I had no friends for a second.
Aha! It says not your friend. Not your friend. I'm your friend. Is that how that works? Okay, here. All right. I'll wait for him to get back. Until then, Taco Cat. We're gonna learn geometric sequences. Is that what you want to learn about, Taco Cat? I think that's what you asked about, right? Where's Taco? Senor Taco. Taco, taco, taco. Wait, is he Taco Cat on, or is he's Monkey? He's Monkey. There he is. Yes, hi there, Monkey. Okay, cool. All right. Geometric sequences is one where, okay, cool. Yeah, these are important. And actually, this is going to get into, Teacup, when we go over your question, after Jamarcus's, this is also an example of what we call like a sequence. This is kind of cool. Yeah, this right here is called like sigma notation for a sequence. This right here. This is also called a sequence. You guys know what a sequence is?
Yeah.
And what do you think of a sequence is, Minion?
A number sequence?
Yeah, like a number sequence. Yeah, what's that?
Basically, like a series of numbers that are related to each other in some way.
Good. Yeah, related into some, yeah, in a certain like pattern, right? So let's say I had this. Let's say I had some numbers: 2, 5, 8, 11,
11.
14, ... Could you guess what the next number in the sequence is?
Yes.
What would it be?
17.
Good. Yeah, nice.
Nice.
Be 17, right? Okay. How did you know the next one was 17?
Because there's a pattern between all the numbers where there's like, in between there's 3.
Good, exactly. Yeah. Do you see this as being plus 3? This is being plus 3. This is being plus 3. Plus 3. Yeah, good. So then you're like, okay, duh, this is plus 3.
That's dope.
It's 17. Okay. This is what's called an arithmetic sequence. This is like the technical term that you're going to see in your classes. They're going to call this an arithmetic sequence. That's what they call this. All right. Which is numbers that have what's called, this right here, this is called the common difference. Have you seen any of these terms before? Common difference or anything? Yeah. This is kind of cool. So this week, if we wanted to say, like, for instance, this is how they write it. They write it as like A with a subscript, A sub n, where this, for instance, this is A1, this is A2, this is A3, and so in fourth force, you know, this is, what was this, A4, A5, this is like A6, okay? So this number down here, this n, refers to which sequence it is, right? Oh, you got 100% on the homework. Nice, good job, Marcus. Oh, probability. Yeah, Noise's favorite. Teacup's like, my nitro runs out today. Uh-oh. We definitely do. We do still need nitro. Okay. So, one thing that could be used. So, you see how this is like the first term, the second term, the third term, and the blah, 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 up to the sixth term? All right? What if I asked you, for instance, what is the 90th term? Another way to write this is A sub 90. Do you know how you'd figure this out? You forgot? Okay. Well, let's try to remember it. There's an equation for this, okay? This is the equation that you want to know, okay, for an arithmetic sequence. It's this one here. Let's blow this one up a little bit. There we go. This is the equation, all right? You have to use a formula. Good. Yeah, but let's explain what this formula is. So this is A, we say A sub n. That means the nth term, okay, is equal to A1. This is the first term, plus whatever n is, minus 1, multiplied by d. And this is called the common difference.
Wait, what does sub mean?
Good, okay. So subscript just refers to, like, which A this is, okay? So, for instance, A sub 1, A with a subscript 1, means the first A term, which in this case is 2.
Oh, okay.
You see how this is A sub 3? That's the third A term of the sequence. And so if I wanted to figure out what the 90th term is, right, like way over here, I could keep writing terms, right? I could go like 20, 23, blah, 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 blah. This would take forever, though. We don't want to do this.
No.
So we come up with an equation that would help us figure out what the 90th term is, all right? And this is what it is. It's this. D is 3. Good. Yes. So in this case, right, if we want to look for the 90th term, we're going to say A sub 90, which is A subscript 90, which means the 90th term, the 90th A, which has to equal A sub 1. Which one was A sub 1 here? The 2. Good, monkey. Yeah, see, this was 2. Good. So this is going to be 2 plus, okay, and then n minus 1. What's n if we're looking for the 90th term? Dude, I love the Zalgo text. Yeah, so what might help you guys here, right? See how this is this n here? That's the same as the n here. Okay? So if this is 90, good. N minus 1 is 89. Do you see that? Do you see how it's n minus 1? N, 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 N. Okay. Good. And then you already said this, Taco. Good. This is 3. Good.
Nice.
Okay. So now you can figure this out, right? So this is equal to 2 plus 89 times 3. Okay? Which ends up being, this is going to be 267. This is going to be 2. So you get a final answer of 269.
Nice.
Yeah, good job. Good job, monkey. Yeah, good. Yeah, do you see that? See that? So that's how you figure out what the 269th term is, all right? Now, what could be kind of, I'll do one more thing here, which is kind of useful, all right? And we'll talk about sums. So a good thing, Taco, would be like next time, or if we have time later today, I'll teach you what a geometric sequence is, which is similar to an arithmetic sequence, but there's just some slight differences in the formula. But let me show you how you figure out what a term is in a sequence and what a sum is for an arithmetic sequence. Next time we can do geometric sequences. Okay, so the other thing we can learn is called the sum of a sequence. And let's see why this would be useful, okay? Let's say, for instance, you're playing Fortnite, okay? And you know on the first day you play Fortnite that you're going to get, I don't know, let's say you get 7 kills on the first, 7 kills on the first day playing Fortnite, okay? 7's pretty good, right? Yeah, 7's pretty good. And then let's say every day the number of kills you get increases by 2. Okay? And then what we could ask is, okay, how many total kills or let's say how many career kills, right? Career. You guys call them, this is like career totals, right? The same thing as like total. You have after 1 week of playing. Okay? Okay. Good. Yeah. But let's do a quick review for this so that you can understand like how this works. Because this will come in handy when we do sums later with Teacup. Also, it's getting hot. Let me turn my fan. Okay, so let's have A sub n be the number of kills you get on a certain day. All right. So on the first day, right, we know that you're going to get 7. How many kills are you going to get on the second day? 9. Good, right? then the next day 11, then the next day 13, and then so forth and so forth, right? Okay. And actually, we can write it all of them because it's not that bad, right? 15, 17, 19, 1, 2, 3, 4, 5, 6, 7. Okay. Right, you see that? Good. Okay. Then what we can ask is, for instance, what is the total number of kills you got in those 7 days, right? This is called S sub n. And in this case, so this one keeps going on forever. We could figure out, for example, what S7 is. S7 means you're going to add up A1 plus A2 plus A3 plus A4 plus A5 plus A6 plus A7. Okay? That's one way to do it. Do you see how S7 is adding up the first 7 number of kills you got, the first 7 days? Okay. So, for instance, like S3, what would S3 be? What days would I add up? You would add up to A3. So you would do 7 plus 9 plus 11. So it's this one, right? A1 plus A2 plus A3. And A2. Good. Yeah, very good. Now, yeah, Monkey, little thing. When we say subscript, you want to write it like this. You want to put like a bracket underneath. When you do this with that, this means exponent. Or they call this superscript. Yeah. Yeah, just a little hint. It'll help you guys out later with stuff. Okay. Now, you can see, you could calculate this, right? 7 plus 9 plus 11, right? This would be 16 plus 11. This would be equal to 27, right? Good. Yeah, okay. There's another way to do this using a formula, okay, which has to do with this. This is it. It's I like this. I like this second one is what I like. Nope. This is the formula I like. I like this one right here. Okay? So S sub n is equal to n over 2 of A1 plus AN. How to talk to women without Buster, Marcus? Yeah, I didn't get that one either. Okay. The cool thing of how this works. So here, let me show you this monkey. Taco Cat. What this like intuitively means. Do you know how to take the average of two numbers? How would I take, for instance, the average of the first term and the second term? What would I do? How would I take the average of the first one and the second one? You add them and divide by 2. Good, yeah. That's exactly what this formula says here. So this formula says, if you want to figure out, for instance, S sub n, which means the nth, so the sum of the first n sequence, n elements in the sequence, you take the average of the first one and the second one. Sorry, the first one and the last one. And then you multiply it by how many elements there are. So, for instance, S3 would equal the first one plus the last one. The last one in S3, right, is the third one because you're adding up to the third one. Divide them by 2 and then multiply by 3. Because they're 3 elements between A1 and A3. So watch how this works.
Complicated.
But it's pretty simple. Do you see how you just average the first one and the last one? Right? Just add these two, divide by 2.
No candy.
And then you multiply by how many there are in between. Why is there a 3? Because that's the n right here, right? So S sub n, right? The sum of the n number of elements. So in this case, sorry, this was S3, right? Yeah, is this part right here is this. It's the average of the first one, and this is A sub 3, the last one. And then you're multiplying by the number of elements, which is 3. Yeah. It's kind of cool. So if we were to do it in this formula, right? See how this would be 7 plus 11 over 2 times 3 7 plus 11 over 2 is 18 over 2. 18 over 2 is just equal to 9. 9 times 3 is 27. What's up, Teacup? Yeah, Teacup, this is going to be useful to you later. Yeah, see how that works? Yeah, very cool. So, let's say, for instance, I'm trying to find the sum of the first 7, okay? Let's get even crazier. Let's say how many you will have after 2 weeks of playing. Okay? That would be S14. Okay? So how would we calculate how many career kills you have after 14 days of playing? Yeah. It's a little tricky, but I think you can get it. I think you can get it. Let's remember here, right? S14, which is this. And yeah, don't use this formula is like tricky. This one's confusing to me. I don't like using this one at all. This one makes more sense to me. So what is n if we're looking for the sum of the first 14 terms? Monkey. Ooh, 7 plus 33. All right, let's see where we got that from. Okay, so 7 is the first one, right? So you're right. It's S1 plus, this is going to be S14 over 2. So you're right. This one is 7. Did you figure out, did you figure out this one was 33? Sorry, this is not S1. Sorry, this is A1 plus A14. Yeah. And then, yeah, what we had to do is we have to use this formula. Where do we put it? This one right here. Good. Yeah. So we have to use this to figure out A14. So A14 is equal to 7 plus 13 times... What did we say it was? Was it 2? 13 times 2? Yeah, good. No. You got it right. You got it right. Yeah, no, you got it right. Yeah. 33. Yeah, good. Because this is 26. Yeah, good. So this, 33. Good. So you're averaging the first one and the last one, right? So this whole thing is just equal to 20, right? 7 plus 33 is 40 over 2 is 20. And then you multiply by n, which is 14. So good. This gets you 280 kills. Nice. Very good job. Very good job, Taco Cat. Yeah, good. Did you learn something there? Or, did it refresh your memory? Yeah, nice. Yeah, so next time we can do geometric sequences, which are a little trickier. Yeah, very cool. All right. Yeah, tomorrow. We can do it tomorrow. Yeah, for sure. Good stuff. Okay, nice. Let's see. Next question is Jamarcus's. Jamarcus with the pain. Always bring the pain, dude. All right. Okay. Wow. Okay. So we did this one before, I think, didn't we? Where did we find it? Was it here? No. Yeah, this is it. Yeah. Well, okay. So we said. Change of kinetic energy. I wonder if we're gonna use a result from the first one to do this one. Yeah, we did A. We got this, I think, right? We got delta E over KE. Wait 1 second. Let me get rid of all this scratchy work. I was so mad at this. Okay, cool. Yeah, let me copy this over. just so we're not having to like rederive the wheel like all the time. Oh, that was very big. Okay, whatever. Can make this big too. And then let me see if there are any other like equations I liked that we had. This is like kind of useful, I guess. And then what else do we have that was useful? Or maybe, did I do Larmor radius here? Is this where I did it? Oh, this is where I did it. Yeah, okay. Okay. And where's the last bit? Last bit's probably right here. This is good. It's good to have as well. Yeah, that's good. I wonder if we're going to have to do more calculus on this because the radius is changing. Yeah. All right, here we go. Okay. So it says using the typical size of an atom, which is 1 angstrom. I think an angstrom is 10 to the minus 12. What's one angstrom? Oh, it's 10 to the minus 10. Okay, 10 to the minus 10. It is when the energy hits 0. That's correct. So here we go. One angstrom is equal to 10 to the minus 10 meters. And a femtometer, that's 10 to the minus 15, I believe. Oh, what? Wait. No, yeah, 10 to the minus 15. Yeah, dude, what are they saying here? Oh, that's a different femtometer. 10 to the minus 15. Okay. All right. Let's see. Got you. Okay. This is okay. So this is the energy lost in a revolution, right? It was this. This is the energy lost in a revolution. Wait, but do we know the velocity? I think we want this to eventually equal -1, right? Because if the amount of energy lost is equal to the total kinetic energy, then that means it eventually spirals inwards. Yeah. Fentanyl meter? No, it's femto. Femto's 10 to the minus 15. I gotta think how we do this though. So this is energy lost in 1 revolution, right? And then I guess we want to know how many revolutions do I need to do in order to get to... Okay, this is kind of cool. So here's what they're saying. So they're saying the nucleus is... Oop, what is it? Is the nucleus a femtometer? Yeah, nucleus is a femtometer. And wait, first of all, is that the rate? I believe that's the radius. Or wait, is that the diameter? I'm gonna assume they say it's the diameter. Okay. Well, okay, we can. Yeah, so this would be 1/2 times 10 to the minus 10. Right? And then this distance right here is going to be, oh, this is going to be really small. This is going to be 1/2. Oh, wait. Okay, wait. Okay. This is the whole thing, right? This is 1/2 times 10 to the minus 10. And then this right here is 1/2 times 10 to the minus 15. And I think essentially we want to know how many times does it have to spin in order to decrease its radius. Huh. Hmm. Oh, wait a minute. I think I know something we can do here. How long? Okay. And then what was the other approximation we had? We had, right, Q is equal to mv squared over r, and then we also said that a was equal to v squared over r. Okay, so let's plug some things in here real quick. So dE dt is equal to -2/3 q squared, which q squared is mv squared r, right? And then a squared is going to be v the fourth over r squared. And then we also have a c to the third here, right? Wait, q squared is m v squared times r. How do we get this to v to the third, though? How do we do that? One sec. Oh, okay. Uh-huh. And I need this to equal 1/2. I want to know when this total change. Okay. So -2/3 mv squared r v the fourth over c to the third r squared times t. That's equal to the total change in energy. I need this to equal 1/2 mv squared. Yeah, no. You don't need to do that. No, I think this is it. Here's what you do. I think you move this over here, right? dt. Integrate both sides, right? And you're just going to get that the change in energy. So, Jamarcus, if you move this over here. Let me move this all over. Okay. No, I got this, Jamarcus. Okay. Integrate. I can just say that the change in energy will be equal to all of this times the change in time. It's kind of convoluted because the velocity is going to change, right? As we go further in. So velocity by definition is going to change. Fuck. But maybe this like crude approximation works. Because I want the change in energy to equal the whole -1/2 mv squared. I want it to drop the whole thing. Let's just see if we get like the right answer here. Let me think. But the radius is changing as well. Let's see. Let me see. I remember this. I remember I found this question on the internet. I want to see how they do it. If I just can see like how they start it, then it's pretty easy for me to get it. What was it? This goofy? Yes, Minion. Don't worry. We'll get to yours. Okay, here we go. This is it. This is it. I got it. One sec. One sec. Oh, this is kind of tricky. Yeah, yeah, because the R is changing. Yeah. Yeah, I see how the one of R is getting in there. Okay, one sec. There you go. I got it. I got it. This is actually a cool explanation. I like this one. No. This is a cool question. That's a cool question, Jamarcus. Just give me a second. I have to remember a lot of E and M from this, which I haven't taught E and M this year yet, because it doesn't come till later in the semester. So I sometimes forget things. Whatever. There we go. And then Minion will do yours. Yeah. I know you gotta go. Okay. So, total energy is equal to kinetic energy plus potential energy, Jamarcus. Kinetic energy is 1/2 mv squared. Potential energy for a particle that's, let's say a particle here that's orbiting another particle here. So the electron, right, orbiting the nucleus, which is positive. That's equal to minus q squared over r. What's up, not your friend? Okay. So, cool. And then, let's see. 1/2 mv squared. Where is this coming from? Q squared over 2r? Oh, did we have a radius formula before that said that? One sec, what was that? Oh, we did have this. Wait. Q squared equals mvr squared? Okay. Yeah, and then we also had this. Put this in. Yeah. From before, we said that q squared was equal to mv squared r, I believe. Or, no, mvr squared. Wait, what do we say here? Yeah, mv squared r. That came from this. Coulomb force was... Yes, and that's equal to centrifugal acceleration. Okay. So it's mv squared r. Yeah, okay, good. So then from this, Jamarcus, you can rewrite that v squared is equal to q squared over mr. And if you plug that into here, you end up getting the m's will cancel. You get q squared over 2r. Yeah. Good. And then this gets you to this. Okay. So this is what the energy is. Energy is equal to negative q squared over 2r. Yeah. Knocked on doors for an hour and only sold... Hey, selling 14 raffle tickets is good. I mean...
That's dope.
Good job on at least putting some effort in. And yeah, not your friend. We'll get to yours. Okay. So then we had this. So dEdt is ddt of the energy. The energy was this, which is also equal to this. This was given in the beginning of it. So you have ddt of this is also equal to this, and then the derivative of q squared over 2r where is this 4c whatever the fuck, where's this coming from? Oh, okay. Again, they're replacing this. They're saying that q squared is equal to m v squared r. They're plugging this into here. And then I think they're saying... Oh, no. Well, yes, yeah, wait, sorry. Where's there another 2 coming in, though? Can you just do that? Yeah, I guess you can. Okay. So they're moving this over this. I see. And then I think they're also plugging in this. Yeah, this is actually kind of weird. Sorry. So ddt of negative q squared over 2r is equal to negative 2/3 q squared a squared over c to the third, right? And let's remember the a is centripetal acceleration, which is v squared over r. Okay. So right off the bat, I can replace this with v squared over r squared. And then it looks like we're getting rid of the q's here. Getting rid of the q squareds. We're moving the 2 over. And we're moving the negative over. Okay. So now I have ddt of 1 over r is equal to 4/3 1 over c cubed. Okay, good. V squared over r squared. Aha. Okay. Very cool. Okay, that makes sense so far. Can someone start a raid? What type of raid? And then this is a differential equation you have to solve, dude. This is very advanced for even college would be a lot here, man. What's happening here? They're multiplying. Wait, there's an r squared here. How are we getting another? We're getting another r. Oh, okay. This is a chain rule. Yeah, chain rule. Cool. drdt, and then okay, r squared drdt. Oh wow. Wow. Yeah. Jamarcus, yeah. There's a lot of, I can show you how to do this. It's kind of interesting. This is a chain rule you have to do. So the derivative of let's remember, like ddx of 1 over x, that's technically equal to negative 1 over x squared, and then it's like dx. Now if I replace this to, let's say, ddt of 1 over x, that's negative 1 over x squared dx dt. So again, you always do what the derivative of this thing would be regularly, right? Multiplied by the derivative of what's inside. This is a chain rule, is what this is. Okay? So, this becomes negative 1 over r squared dr dt is equal to this beautiful mess, right? Which is 4/3 c cubed, and then this is v to the 4th over r to the 4th, or over r squared. Yeah, okay. Wait. We're missing. A equals v squared over r. Yeah, we already did that. That's just an r squared, though. It's not an r to the 4th. Where is this r to the 4th coming from? Yeah. Oh, there's a typo in this. This is kind of cool. Yeah, this is just over r squared. Now look what happens. This is actually kind of cool. So this goes away. And I'm just given to negative dr is equal to 4 over 3 c to the 3rd v to the 4th dt. No, the integral of 1 over x is ln of x. Yeah. Okay, cool. Yes, and then you're going to integrate this from x initial to x final, right? That's from the initial radius to the final radius. So as this thing moves from the final, this is like x final to x initial, okay? So this is an easy integral. Here, we can move the negative over if we want, because this is just going to be x final minus x initial. Oh, you know what they did? Oh, they rewrote the v. Oh, I see what they did. These tricky little fuckers, dude. Yeah, okay, one sec. Yeah, no, sorry. We gotta fix a couple things here. Sorry. They rewrote v using this. Yes. Okay, cool. Yeah, because this is the problem, Jamarcus, is the velocity changes as this thing falls in. So using this, v squared is equal to q squared over mr. All right? So this is going to now become negative 1 over r squared dr dt is equal to 4 over 3c cubed v squared. So now this is q squared over mr squared. Right, because there's another r here. Squared. Okay, good. So now this is, I see. Tricky calculus. This is now q to the 4th over m squared r to the 4th, right? Now if I move this over, okay, I get r squared, right? Because this is going to be r to the 4th over r squared. This is r squared dr dt is equal to negative 4 over 3 c cubed. And then this is q to the 4th over m squared. Okay, great. Cool. That's what they have so far. Good. Awesome. Okay. Now, move the dt over. Okay. And you can integrate both sides. Okay. Integral, and for the radius, right, we're going from x final to x initial. And the time is going from 0 to t final, is what we say. Or 0 to t. This becomes, the integral of r squared is r to the 3rd over 3. So this is r to the 3rd over 3 from x initial to x final is equal to this, which is negative 4/3 c cubed q to the 4th over m squared times t. So x to the final to the 3rd minus x to the initial to the 3rd is equal to, if I move the 3 over, negative 4 over c cubed q to the 4th over m squared times t. And then, yeah, here's the, they got to put in the mass and the q. Yeah, but okay. They plug in the numbers. So mass, wait, I think they have it in CGS. They have it in grams. No. This is okay, actually. Yeah, you have to check the units here. But I think Q is going to equal to 1.6 times 10 to the negative 19. And then M should be equal to 9 times 10 to the minus 34. That's kilograms, so maybe it's something slightly different. Yeah. Nice, Ethan. Cool. 40 stream watch streak. Wow, that's dope. Plug that in. X final is equal to 10 to the minus 15. X initial was equal to 10 to the minus 10. And then solving for this, you should get T is equal to, it looks like 1 times 10 to the minus 10 seconds. Cool. And then you're done. Wow, that's a hard one. Yeah, I know these. I know the charges and the masses of electrons at this point because I've done them so many times. Yeah, that's a lot. I'm gonna give this to Jamarcus. Okay, cool. All right. Minion, do you have to go like real soon? Is that what you said? You have to go really soon?
Oh yeah.
Okay, cool. Let me do yours real quick. Yeah, because you're in the voice channel. It's all good. All right. Let's see which one yours was. Yours was this, the point stuff.
I was on Twitch, so like Twitch has like a slight delay.
It's okay. It's okay. All good. Point D belongs to the side AB of a triangle ABC so that triangle ADC is equilateral and its area is half that of triangle ABC. What is the measure of angle CBA? Okay, cool. I think we literally just did this yesterday with Jamarcus. Or whose question was this? Who was this? Whose question was this one? Was this yours, Minion? Do you remember whose question this was?
Oh yeah.
Yeah, we're gonna use the same kind of rules here, which was also I think the same. It was the same with this one as well. This was kind of the same thing. Yeah. Okay. So we have A, B, and then we have C. And then they say this is point D, which belongs on side AB. And then ADC is an equilateral. Okay, so this is what they're saying. They're saying, let's try to make that happen. See what we need to do to make that happen. I'm like trying to figure out how that would work. I guess it's like this. Okay. So they're saying that ADC is an equilateral. Okay, so this is equal to this is equal to this, right? And they say that ADC has half the area of CBA, which is of the whole triangle, right? Okay. Do you remember I did this with a geometry proof yesterday with someone, whoever this was. But that's what this was. So anytime you have a median inside a triangle, that's going to cut the triangle into two triangles of equal areas. Okay? So, let me just, median. This is so funny how I did this yesterday with a different student, but all the questions kind of relate to each other. Yeah. Okay. Right. And then do they have just a picture of this? I just want a picture of this. Yeah, this is cool. It's really cool. It's really cool actually. Yeah, if you want to know why this does, this has to do with your whole thing of the equal heights or the altitudes being the same.
Okay.
If your teacher asks. Okay. Sorry. All right, where was it? Okay, this is it. Yeah. This is the whole proof, okay? So, if you have a big triangle, right? And it gets cut into two smaller triangles like this. Okay? Do you see these two, Minion? Do you see these two small triangles?
Oh, so they share like the same height.
They have the same height, right? Exactly. And they also have the same base. If this is a median, right? It cuts this in half. But both triangles have the same height. So they're both going to have the same area. Right?
Okay.
Okay? So we said that this cuts this triangle into 2 equal parts, right? Because they say that this area is half the area of the big triangle, which means that these 2 areas have to be the same.
Yes.
So what does that tell you about the length of this side?
It also has to be equal to 80.
Yes, it has to be equal to 80, right? Which is also equal to this, which is also equal to this. Good. Okay, this is an equilateral triangle. What do we know about equilateral triangles in terms of angles?
But each of the angles are 60 degrees.
Good.
Nice.
Exactly. So this is 60, this is 60, this is 60. Okay. How much is this one going to have to be then?
120.
Good. Right? This is going to have to be 120. Okay, cool. So we're close. Okay. And then even cooler, watch this. This is pretty fucking dope. What type of triangle is here? What type of triangle do we have? It's a certain type of triangle.
Isosceles?
It's an isosceles. Good. Because this side is equal to this side, right?
How do we know that?
Because, remember we said this was an equilateral triangle. It means all the sides are the same. This was a median, which means that this side had to be equal to this side, right? So if this is 120, what do we know about these angles then? What do these have to be?
Two are the same and add up to 60 degrees. And
Good.
Each of them are 30.
30. Very good. Very good. Okay. So now, can you see what the angle of CBA is? What is that going to be?
That's gonna be 30 degrees.
There you go. Good. That's a pretty cool question. I like that one. Here, you want me to download that for you?
I don't think I need it, but yeah.
Yeah, I'll give it to you anyways. Very cool. Dun, dun. Nice. Awesome. Good job. Yeah, that's a See, now I'm starting to not hate triangles as much because I've worked on so many of them with you guys.
Hold on, I'm gonna redeem some MT coins using Twitch.
Yeah, do that. Yeah, I will process those. Don't worry, I'll process those. Good to see you, Jamarcus. Yeah, have fun at dinner. And then Jamarcus, if Jamarcus wants the... Yes, I saw that. Nice, 500. Awesome. Okay, then here. And then at Jamarcus, there's the solution to part B. And then if he really wants it, I'll download this as well for him. You probably got to run to dinner as well, right, Minion?
Mhm.
Yeah.
Dinner.
Or dinner, or what is it, lunch? What time is it over there? I don't know.
8:03 p.m.
Oh, that's after dinner. For me, that's like dinner, because I ate dinner pretty late. I ate breakfast at like noon today.
Well, dude, these I'm just stuck in the middle of these math questions, so I just came to ask. But
Okay.
Then I have to get on task again.
Okay, cool. Well, yeah, if you get stuck with more things, just post screenshots, and I can always like try to help you.
Thanks.
Well, thanks for the Prime sub, Magentar. Is that M-E? Yeah, Magnetar. Magnetar. Dub, dude. Thank you. Oh, we're at 9. We're almost at 9 out of 10. That's super cool. Look at that. 9 out of 10 subs. Thanks, man. Appreciate that. All right. Let's see.
I redeemed the MT coins 2 times.
I saw that. Good job. Good job. Yeah, don't worry. I see that all in a queue. If you guys are ever wondering, like, that always gets sent in here. I have a reward queue, and these always show me exactly who has what stuff. So don't worry. I don't forget it. But then I have to go through and manually put these into the server. So that's why there's always going to be a little bit of a queue, but I'll get to them. Okay. Not Your Friend was out, but now Not Your Friend is back. Not Your Friend, did you want to do your question real quick? Yes? Okay, cool. All right. And then Teacup, you're next. Teacup is next. All right. Base of a cuboid. What the hell is a cuboid? Excuse me? Cuboid? Oh, okay. So it's... So it's just a cube? Or it's a rectangular cube? 6-face solid. All its faces are quadrilaterals. It means like a cube. Okay. It's kind of cool. Yeah, a rectangular cube. Why don't we just call it a rectangular prism? What's the difference? Okay. Of height 1 meter and is a square. Okay, so it's basic. Okay, whatever. The length of a side of the base is 25 centimeters. Okay, cool. Let's draw some pictures. I like drawing pictures. I am artist today. Okay. So this is 25 centimeters. This is 25 centimeters. Cool. The container is filled with water to exactly half its height. Okay. Oh, okay. And then, okay, then they say this. This is a meter. Okay, not so bad. Well, okay, I can't really draw things today. There we go. Better. And then here we can do little dashy lines for everything else. Wow, look at that art. Okay. And then, not your friend, they say this is a meter high, okay? But I don't want to put a meter here, right? Because if I put 1 meter, that has, like, the different units. What should I put here for the height? Instead of 1 meter. Little quick quiz question. They say the base is a square. Yeah, I agree. Is height 1 meter? Yeah. The base is square. I agree with this. The length of the side of the base is 25. And then they say this is probably a meter. So this is probably 100 centimeters, I think. Right? Okay. But then they say the container is filled with water to exactly half its height. All right? So that means that it's going to be filled up to here. Right? Half the height. Or here, we can make this with blue. Okay. This is the first time you see me draw something good?
That's dope.
Yes, thank you, dude. I'm trying today. Okay, cool. All right. How do I figure out the volume of water? How do we figure this out? What's the volume equal to? Base times area times height. Yes, good. Okay. So base area into the height, right? So that's 25 times 25 times the height, which if it's half filled is going to be 50, right? So this is, oh man, what's 25 times 25? Is that 625? Where's my, wait 1 second, let me get my calculator out. Calculator. Okay. There you are. No, okay, cool. 25 squared. This is 625. Okay, good. Times 50. Okay, so that's a lot. So this is going to be 31250 cubic centimeters. They also write this as like cc's sometimes. Cool. Monkey, you're okay in the chat, dog? You cat dog? Are you okay, dog? Okay. All right. That's half the volume. So here's kind of the hard part here. They say Randy has several identical solid right circular metal cylinders of unknown base radius and height 10 centimeters. To find the base radius of R, she puts them one by one into the above container half filled with water. When exactly 25 of them are put in, the water reaches the level of it being completely filled. Show that the radius is this. Okay. How do you think we do this one? Do you understand what's happening? Like we're taking here, I'm gonna get my drawing skills on point again today. Let's use black. Let's use black for this. Yeah. Well, actually black's gonna be kind of hard to read. Let's make the spheres blue. So she's taking like a bunch of these, I think. No. Yeah. So she's taking a bunch of these. which are 10 centimeters tall, and we don't know what R is. And she's putting them in here until the water fills up all the way to the top, right? Yes, it is convergence divergence. We'll get to that. Yeah. Okay. And she puts exactly 25 of them. Okay. So here's how I would approach this. I know that the volume of water when it's half filled is this. And I need it to be completely filled when I put in 25 of these. So if this is half the volume, right, times 2 is the total volume. Which would be that it's full. Which is also going to be this much water plus this much volume in cylinders. This is the volume of 25 cylinders. Okay? So, let's figure out what the volume of a cylinder is, right? Volume of a cylinder is equal to pi r squared times the height. Yeah, exactly. Good. Yeah. Exactly. So pi r squared, and then the height of each one of these cylinders is 10, right? So this is 10. That's a single cylinder. So times 25 needs to be equal to this big number, which was... Let's keep it as this. I'll show you. This actually comes out nice. You won't have to use a calculator. This is going to be 25 times 25 times 50. Okay? Right, that's the half volume. You can cut off what? What am I cutting off? Oh, when simplifying? Yeah, so watch. So instead of writing this big number out and then using a calculator, I'm going to go back to how we calculated it, which was just 25 times 25 times 50. That's what this was. And then look what happens. This is actually kind of nice. Do you see how there's a 25 here and a 25 here? These are going to go away. Goodbye. Goodbye, right? And then watch this. 50, let's remember this is the same thing as 25 times 2. Okay? So now I have pi r squared is equal to 25 times 25 times 2, right? Because we still had another 25 from here. Okay? This is the same thing as 25 squared times 2. Which, okay, watch. This is actually kind of cool what's going to happen. I'm going to move the 10 over. So I have pi r squared is equal to 25 squared. Well, here let's actually just keep it as this. Sorry, let's say it's 25 times 25 times 2 all over 10. And watch this. 2 over 10 is the same thing as 1 over 5. So this is 25 times 25 times 1 over 5. I just took this. 2 over 10 is 1 over 5. So now this one is going to turn into a 5. Okay? Now I can move the pi over. R squared is equal to 25 times 5 all over pi. And now when I square root both sides, okay, so square root of r squared, square root of this, so I get r is equal to the square root of 25 times 5 all over pi. This is the same thing as the square root of 25 times the square root of 5 over pi. The square root of 25 is just 5. So this gets me 5 root 5 all over pi, which is what they wanted, right? Do you see how that works, not your friend? Yeah, it's nice. Yeah, there's some nice algebra here. Again, we could have done this with but I want to teach you guys how to not need a calculator to do things. And once I'm seeing squareds, I'm seeing this is squareds, and then like, oh, this is a 5, and 5 is also like a factor of 25 and stuff. You can just keep going down. Yeah. Okay, there you go. So you get that. That's pretty much done. This, just put in the number, right? R is equal to 5 over 5, and then they say over 3.14. Fine, we put that on a calculator. That's pretty easy. What's up, Hypatia?
Hello?
Yeah. Hypatia, what's going on? What's going on?
That's dope.
Can you hear me? You hear me, Hypatia?
Yeah, I can.
Good, good, good. Yeah, I
I
was.
think there's a latency, probably with your streaming bot or something.
Oh, is there? Probably between my.
Like you took a little bit longer than usual when you replied to me or just
Oh.
me. I guess that
It could be the internet or whatever. Yeah. Okay, so not your friend. This is 6.31. There you go. Estimation, and you're done. Good stuff.
That's dope.
You got any question that you don't solve you want to ask?
I want to.
me?
At the end of this, can I go through the code you sent me for that geometry proof?
Wait, what? Oh, that one. The alpha geometry. Yeah,
Yes.
I wasn't able to get it running because there wasn't a published notebook. I can try to get it running.
Oh, okay. Yeah, I was wondering how that works because I see the code.
So,
Maybe you can
remember
help me
last
understand
time
like how
you-
the code works.
Yeah, remember last time you told me or everyone else that you hate geometry or
I
those
do.
kind of proofs.
I do hate. Well,
Yeah,
I
you
think I'm getting better at it. I had a geometry
No,
question
you
today. I
can't.
got kind of better at.
No, you can ask the GPT to do it. So from what I can tell, the link I send you, you just
Yeah.
describe or define your geometric question.
Like which things are fixed and which
uh,
things aren't.
Yes, in the syntax described as like in that example file, and then you can run it, and then it's probably going to search for a proof heuristically.
Okay. Okay. But how will it search for it? Well, is it looking through other proofs that have already been done? Like how does it do it?
I think it's a language model.
Oh, okay. Okay. So it just tries to find something. It's basically like me going into Google or Chegg and typing in the question
It's more
and looking
like
for something.
ChatGPT.
Yeah.
Have to asking ChatGPT and tell it you did wrong until it finds
Uh-huh.
something.
Okay, I got you. Cool. Yeah, we can go over that. Here, I gotta answer, let's see, just teacups and then equities. And then yeah, let's take a stab. Because I'm getting more confident now with triangles and geometry questions. Like this one I was able to get pretty well. And then some student last time gave me this one, which was it was dividing this thing into a bunch of different quadrilaterals, and the solution ended up being creating a lot of like small triangles is what it was. It was doing stuff
yeah.
like this.
I think I did that like the first time I saw you on the
Yeah.
stream.
Yes.
Do you remember it?
Yes.
I told you to start from the lower, like the right bottom, like
Yes.
draw a line to the center, like that thing.
Yes. Yeah, it's so cool. I am getting more comfortable with how, yeah, if it cuts it into medians, then they're all the same. They're all the same volume and stuff. It's area. Sorry.
Yeah.
It's pretty cool. Teacup, come on the stage. Let's teach you about divergence and convergence. Diverging and converging series. This is cool. What's up? Okay. So did you see earlier, Teacup, what I was working on with Taco Cat?
No, I did not.
Oh, okay. Well, then I'll go over it briefly real quick. Okay. Do you know the difference between like what a sequence and a series is? Teacup.
Huh?
Do you know the difference between a sequence and a series?
Sequence is a series of numbers.
A sequence is a series of numbers. Okay. Kind of.
Sequence has a pattern, I'm pretty sure.
They both have patterns, okay?
I've been lied to.
Yeah. A sequence is what the individual numbers are. So these are the numbers in a sequence. A series is putting a plus in between them. You just add them all up. Okay? So for instance, this is a sequence. This is like AN as a sequence. And see how this is like 7, 9, 11, 13, right? These are different elements, okay? The series would be adding these all up. So for instance, if I wanted to represent this would be from n equals 1 to whatever, infinity. This would be 7 plus n minus 1 times 2. This is what this looks like in what we call sigma notation. All right?
Huh. Yes.
So how this works is this is like code. It's like running a for loop in code. So what you end up doing is right. Isn't it like a for loop Hypatia? Basically, it's basically like running code. It's pretty cool.
I just text you a joke I made about today, but later when you finish this question, you can look at it. It's
Okay.
related to series.
Okay, cool. No, I'll look at it. So for instance, Teacup, what I do here is I put n equals 1, right? When n equals 1, this is 1 times 1, which is 0, which is 2, right? Do you see how, like, for n equals 1, the number is 7? What would the number in the sequence be for n equals 2?
Until n equals 1, and that's 7.
Mm-hmm.
What
Well,
would
and also, I
Sounds
guess
like it.
another thing is that it's not quite a for loop. It's a sometimes you can't really order the summation. Like with this one, of course, you can
Yeah.
start adding from the first terms, but sometimes you cannot.
Oh,
The
if it's
sum is
if it's
only
telescoping, you mean? If it's a telescoping series, yeah.
Not quite. I mean, if the series is formal, in a sense that like a formal power series or a formal Laurent series or things like that.
Oh, yeah. I know what you're saying. Yeah, it changes a little bit. I know what you're saying. Yeah. Okay, but for basic series that we're doing here, right, Teacup, what would it be for n equals 2? What would the next element be?
Would it be n equals 8?
No. n equals 2. 2 goes into here. So this is 2 minus
Okay,
1.
So 2 minus 1.
Mm-hmm.
No, so it's 7 plus 1,
No.
2.
7 plus 1 times 2. Yeah, which is what?
7 plus 1, that's 8 times 2 is 16.
No. See, this becomes 2 minus 1, which just becomes 1
Which is 1.
times 2, which is 2, plus 7, which is what?
Oh, 14.
No.
What the hell you mean?
Okay, look, Teacup. 7 plus 2 minus 1 times 2. 2 minus 1 is just 1.
Jesus Christ. Okay, it's 9.
Yes, it's
Jesus
9.
Christ.
Okay, it's all right, dude. We're gonna get the hang of it. All right, what's n equals 3?
2 times 2, that's 4. 7 plus 4.
Yeah?
It's 11.
11. Starting to see a pattern here?
Yes.
Do you see how it's the same as here? 7, 9, 11. The next one, right? Yes.
2.
Good. Exactly. This would be 13. Good. Okay, cool. So, that's what the individual elements are. This tells you what n you start at. So I start at, for instance, n equals 1. And I'm going to add up to, this is where we end at, okay? So let's say this is 3, all right? This means you start at the first one and you end at the last one, but you add them all up, okay?
Okay.
So, for instance, I would do this one, plus this one, plus this one, right? What would that be equal to?
Let's see, got 16 plus 11, which is 27.
Good, 27. Yeah, good. So 27, okay? All right. Cool. This is what the sum of a series, or what a series is equal to, okay? Notice here, Teacup, right? That if I keep increasing this number, right? If I keep adding more terms, what happens to the sum of the series? Does it go up or go down?
It goes up.
Keeps going up. Is it ever going to stop going up?
No.
No, right? Because you can see, right? As I keep going up, right? The numbers keep going up. And eventually, when I go to infinity, which, I don't know, you can never really get to infinity, you will have added up infinite number of numbers, and all these numbers will be infinitely big, right? So this is what's called a diverging series. Or diverging infinite series is what we say. The reason why we say it's diverging is because if we tried to add up all of the terms, eventually it would add up to infinity. Yeah.
Would a converging be what doesn't make that?
Exactly. Let me show an example of a converging series. Let's say we have n equals 1 to infinity, And let's say it's 1 over n to the third, okay? What would the first term be?
Well, let's see. We got 1 over n to the third, and that's n to the 1. So that's 1 over 1 to the third.
Good.
Which is, what is that 1?
1. Cool. Good. What's the next term?
Well, let's see. Now it's 2 to the third. That's like a decimal. It's like point.
Now just use that as a fraction. What is it? What is that as a fraction?
Oh. 1
What's
over
2 to the third?
2 to the third.
Uh-huh.
2 to the third is 8.
1 over 8, right? See, because it's on the bottom?
Yes.
Okay. Then the next one would be 1 over...
27.
Good. And then... I don't know. Do we want to do the next one? Is it 64? 64 the next one? 4 to the fourth?
It's
4
64.
to third? Yeah, it is 4 to 64. Okay.
64 and that's 125.
Okay, so here's a cool thing, all right? So I have 1, right? This is like my running sum is what it is. I start with 1, then I add an eighth, okay? So up to here, we're at 1 and 1/8, right? 1 plus 1/8.
Yeah.
But then I add
Right,
1/27th, and then I add sorry, this is 64. 1/64th. Do you see how I'm adding less and less and less?
Yeah, so it won't reach it.
So eventually, your terms become so small that the sum of adding up more and more terms doesn't really do anything. You know, you can think of like, okay, what if I'm up at like n equals 100? All right, now I'm adding 1 over 100 to the third, which is 1 over 1,000,000. Right? Which is, that's really small. Like there's no point to this, right? So it turns out that this series does what we say call converge.
Because it doesn't reach infinity.
Yeah, so there's some trickiness here because technically this term, this is called I think it's called the p-test. So this would be 1 plus 1/2 plus 1/3.
That was called the input test.
Yeah, well, no. The reason I'll show you why it's called a p-test. Cole just said p. Yes. This technically diverges. It's weird. Because I know, looking at it, right, you're like, oh, but the things are getting smaller and smaller, right? See how you're adding a half, you're adding a third, you're adding a fourth, you're adding a fifth?
Yeah.
But it turns out that these things aren't getting small enough quick enough. So as you go out to infinity, this actually doesn't get small. This gets small very quick, right? We go from 1 to 1/8 to 1/27th. This is already like 0.03. Whereas here, we're
But
still at
once it says-
0.33.
It's just gonna go on till it gets to the next. It's just gonna go on.
Yes,
like, 1 to the 6th, to the
you're
7th,
right.
to the 8th.
Eventually, you will have 1 over infinity. Eventually, the last term will be 0. Eventually. But
so
it's
slow.
yeah. This is the weird voodoo land of like infinity. Of like infinity isn't actually a place. So you're like, but it's still getting bigger. I don't know. I forget. Hypatia, the proof for this, is this the integral test? How do I prove this again that this diverges? I think they use the integral test, right? Or Penn Center, you probably remember. Like, how do I prove that 1 over n diverges, but 1 over n squared converges? Yeah. So, anyways, what we're going to eventually get to, the integral test works? Yeah, okay, that's what I thought it was. Because you show it's like ln of something. We're going to, what we're eventually, then this is all what, for instance, BC calculus is. So the second part of calculus is all showing how to determine whether a series converges or it diverges. And there are a bunch of different tests we learn. And the first test that you learn
The input
is
test.
called the p-test. And what it is you look at your series. If it's 1 over x to the n, all right? If it's something like this, all right? If n is greater than 1, then it converges. Else, it diverges. I think this also assumes that, yeah. Well, okay. If n is negative, then it flips it to the top. Yeah, which makes it definitely diverges, right? Yeah. Wait until test number 2. Yeah. Okay. So, for instance, teacup. Do you see this? So, what this means, right, is that 1 over x diverges, right? What about 1 over x to the second? Does that one converge or diverge? Teacup.
Hello.
Okay. 1 over x diverges. By the p-test, what do we know about 1 over x squared? What do you got to look at?
Okay, so we need to look at the I don't know the p-test.
Well, that's what we learned here, the p-test. Okay.
Wow.
I think it's x to the p. Is that why they call it the p-test? I think they call it the p-test because it's the power test. All right, whatever. Fuck it. Let's do this.
If p is greater than 1 converges, else it diverges.
Yes, good. Yes, it's x to the p. Thank you. Okay, that had that wrong. X to the n would be bad. That would be confusing people. Yes. Okay. If the exponent on the bottom teacup is greater than 1, then it's going to converge. If it's less than 1, or less than or equal to 1, it's going to diverge. End test, hold up, dude. Don't get me canceled. The end test. Okay. All right. The other thing related to your question, right? So this is an example of a series, teacup. Okay?
Yeah.
Okay. I'm going to show you another thing.
Did you call me earlier? I think I heard you, but I was not in this room.
Oh no, it's okay. It's okay. I was Penn Center answered it. I was wondering how you prove 1 over n diverges or 1 over x. Sorry, x. Yeah.
Yeah.
And it's the integral
That's
test,
called
right?
Harmonic series. It's actually very interesting. It's one of the pole of the Riemann zeta function.
Oh, it's the Riemann zeta function. Wow.
That's dope.
That's Noyce's favorite for sure. Maybe it's Penn Center's.
Yeah, well, I said the R word, the Riemann zeta. It's not a harmonic series if you want to like. Wait, no, actually. Yes, yeah. It's called harmonic series or something similar to that, I think.
Okay, so one other thing I want to show you here, Teacup, real quick, so that because good, I'm glad you gave a basic question here. All right, let's say for instance I have a series, right, which is series from n equals 1 to infinity, and it's 1 over n n equals 1 to infinity, and it's 1 over n squared. Okay. What do we know about this series? Does this series converge or diverge?
Well, it would.
Thank you, Don. What's up, Don? Good to see you.
Wouldn't it converge?
This would converge. Good. Yes. Because again, the power, right, here is greater than 1. Right? Yeah, math raid. Raid. Dude, love it. Thank you, dude. Thank you. Appreciate that. Yeah, if anyone else wants help with math, Don's an awesome streamer. We love Don, the Don father. I learned that from Penn Center during our AMA last Friday. Yeah, he's got a cool Twitch stream. He and also you play DayZ, right? That's a fun game. I've been meaning to get into that. It looks like a more fun version of Tarkov. Right. So this one converges. Okay. So let's say we graphed what this looks like, right, as a function of n. Okay. You see how this would look something kind of let's look at this. Let's make it do something like this, right? Let's say that this is 1 over n squared. Okay. Yeah, I need to check it out. Is DayZ free? Is DayZ free? Or probably a couple bucks on. Fine giving some money to Steam. Nah, $30 or no? Oh, not bad. Yeah. At least, dude, Tarkov I think is like $120 for some of the more advanced versions. It's kind of ridiculous. One second, let me show real quick. Tarkov pricing. Yeah, and it. Oh wait, what? Is Tarkov down? I love how they still call it a pre-order. Oh dear, Tarkov's out. Okay, whatever. Okay, cool. Okay, so Teacup. This is, for instance, the series 1 over n squared, which we know converges. And think of this graph as like what the terms look like, right? So for instance, right, when n is equal to 1, do you see how this would be equal to 1, right?
Yeah.
And then, I don't know, let's say when n is equal to 2, right, this is a half. And then when it's equal to, I don't know, like 3, right, this is equal to like 1/9, all right? So every element is getting smaller, but I know that as I start adding up all these numbers, eventually that will converge to a single number, right? Teacup, right?
Yes.
Okay.
Hello.
Yes. Another way to think about this teacup is to think about this as an integral. Do you see how if I'm adding up all the different numbers, that's kind of the same thing as figuring out what the area is under this curve? Okay?
Yeah.
So one test for convergence of series is what's called the integral test, which means I'm going to convert this series into an integral and see if it goes to a single number. So if I wanted to write as an integral, adding up a bunch of 1 over n squareds, I would just, all you do is you replace this sigma here with this curly integral thing. You have it start at 1. We're going to have it go to infinity. We're going to write down what the function is, n squared, and then we're going to say dn. Okay?
Yeah.
Do we
So
remember how to do
I-
this integral? What is this integral?
So what would it? So you raise the power and divide. Right?
Good.
So it'd be n to the 3 over 3.
Close.
Well,
So
One.
1 over n squared is the same thing as n to the minus 2 dn, right? So then what happens when I raise this power?
n to the negative 1.
Good. Good. So this becomes n to the negative 1 evaluated from 1 to infinity, which is the same thing as 1 over n from 1 to infinity, which is equal to 1 over infinity minus 1 over 1. Or, yeah, that's what it is. Oh, and there's a minus sign here, sorry. Remember when we raise the power, we have to divide by the new power, right? Do you remember that teacup? Since this negative 2
Yeah.
went up to negative 1, we then have to divide by negative 1. That's why this is negative. Okay? All right. And then what is this? Right? What's 1 over infinity? What's 1 divided by the biggest fucking number in the world?
Infinity.
No, it's not infinity.
0.
0. It's 0. It's 0. 1 divided by real big, or what do they say, like BFG? That's equal to 0.
The,
All right.
a big fucking guy.
Big fucking gun, right? Yeah. So this is 0 minus 1. So this is equal to 1, okay? So since this integral went to a whole number, like, you know, a number that's not infinity, that means that this series will converge, okay? Because in doing an integral is like a more complete way of adding up these individual numbers, because we're adding up all the area in between it as well. Right? You see how if I was just adding the individual numbers, I would add this number, then I'd add this number, then I add this number. But doing an integral adds up everything in between. So if everything in between being added up still converges to a number, then adding up the individual, like, quantized, like 1, 2, 3, that will also converge to just a number. So this is pretty cool, because you can also use this to check, and this is what I was asking Hypatia about. You can use this to check why, for instance, 1 over n will diverge. Because let's write this as an integral. Let's write from 1 to infinity of 1 over n dn. Do we remember what this is? How do we do this integral?
The integral 1 over n dn.
Mm-hmm.
So it would be n squared.
No. So this would be the same thing as n to the negative 1 dn. This is a special integral. Because what happens if I raise negative 1 by a power? What does it become?
When you raise negative 1, it just becomes 0.
0. Okay, so this would become 0. But then I would divide by the new power, which is dividing by... What would the new power be? What do we divide by? teacup.
You divide by 0.
Divide by 0. Yeah. Don't do it.
No.
Don't divide by 0. It's bad, right? This is not good. We don't like this, okay? This is a special identity. This is equal to the ln of n. Anytime you integrate dn over n, which is the same thing as integral of 1 over n dn, this is equal to the ln of n. Okay? Just something to know. It's the same reason why integral of e to the x is e to the x. Like, there's just some weird ones, right? Okay. This is being evaluated, right? From 1 to infinity. So then we do it again, right? ln of infinity minus the ln of 1. You know what the ln of 1 is?
Yeah, do not know what the
Okay, it's 0. 0. This is 0. ln of infinity is just infinity. It's a really big number. So this is infinity. So since the integral went to infinity, then we can say that the series does not converge, which means it must diverge. So that's why 1 over n diverges, but 1 over n squared converges, even though, right, both of these sequences get smaller and smaller. Where did I put that number? Where did I put it? Oh, I did it all the way back here. 1 second. Where is it? Yeah. Right. Remember seeing here, like, for instance, like 1 over n cubed got smaller, 1 over n got small, but this one ends up diverging when we add up all the terms. Yeah, of course. Yeah, of course. Yeah, yeah. No. I definitely help people. Are you part of our Discord, Gorilla Chris? That's where people submit all the questions. So here, I'll show you. Yeah, once a week, Sam. You're right. So for those of you that are wondering, we have a Discord. Here's our Discord. And then there's a channel here called Help Screenshots. And so if you just post a screenshot of what your question is, then I go over it on the stream here for free. That's all fun. And you earn points, and we give out prizes and all sorts of fun stuff. So there's our Discord channel. And then there's where you want to post it. There's the thread, I guess. If it's just something like a text question you can type out, you can also put that in the chat, and I can try to help you. But it's easier if there's more information to it, such as like this question that we did earlier. You don't want to type all this. That would suck. So just try to post a screenshot. What's up, Sensation? Sensation, our top donor, dude. I think all the donations have come from you, actually, because it's. Hey, you know what it is? I think you know what is funny? It's at 1775. It's almost that freedom number, 1776.
That's dope. My freedoms.
My freedoms. You know what's his face does that, right? Alex Jones. Whenever he sells things, he puts the price as 1776.
Of course he does.
Yeah, right. Here, I'm gonna show you. It's quite here. Let's see what he's selling. Okay.
If I didn't believe that guy was just a lunatic,
Dude.
then I'd feel bad for him.
Dude, no, I thought he was selling his stuff at 1776, dude. Oh man. Okay. Anyways, not anymore. But yeah, he used to sell his like. He's got some. What was it, like super male vitality or something? I love this guy, dude. He's nuts. such a Texas guy, dude.
Such a Texas guy.
He's so
I know
Texas.
people. He's just a fucking loon.
Dude, he is a loony, but like I love him, dude. Where was it? Alex Jones van? Dude, this is his car. Oh my god, dude. Look at this thing, dude. He did this in Texas. This was in Austin. I went to school at UT. UT was my undergrad. And then he did this where he goes around in this basically bulletproof like survival mobile, just yelling about how, I don't know, the water's turning the frogs gay or something. Oh, he's kind of weird. That vector is not parallel to the XY plane, yo. Yeah, dude, what? What is this thing, dude? Yeah. He's a very, very, very Texas man. There you go. That's it. Yeah, that's it. That's his thing. Yeah. Kind of looks nice though. What the hell is it? It's I believe it's an armored van, armored truck or something is what it is. Type. There's probably a name for this thing. Armored car. It's an armored car.
Freedom Mobile.
Yeah, what is it though, dude? His armored truck. Oh, apparently it cost him $300,000. Wow.
For the armor plates alone, probably.
Yeah, what is it? Oh, it's called the Gurkha CIV. This is it. If you guys want it. Wait, is there a picture of
You
this
can't
thing?
have that. The Gurkhas are ours.
Yeah, wait, yeah, isn't that a thing? Yeah, wait, Gurkha CIV. There we go. There you go. Here you go. You guys want to buy one? You can go buy one. You want to buy one for me? I'll take it. If you guys want it. Okay. All right. Nice. Good job, Teacup. Good question. Great job learning about series and sequences. Next time we'll go over how to do the comparison test and stuff. That's another really cool process to knowing sequences and series. But I hope that helps you out. All right. Let me see. Next up, we got Equity. Equity, you still here, dog? Yeah, screw buying a house, dude. I'd totally buy one of those. Yeah, Penn Center would probably be good for you in Canada, right? Just like some like armored vehicle. I bet that thing
Gotta
can
protect
withstand.
yourself from those moves.
Yeah, I bet that thing can protect yourselves from the. Is it called meese? Mooses?
I think moose is plural in the
mooses.
Yeah.
Moosai.
I'm not doing it.
Yes, Falcon. I do have time. You want to just? Can you post a screenshot of it, or you want to like post a text for it? I'll go through it. Moose has got nothing on that thing.
Plural of
Dude.
sheep.
Was a sheeple? Sheeple, the plural of sheep. Okay, let's see.
Sheeps.
Equity, what's up, dude? Okay, there are 6 greyhounds in a race. Wow, is greyhound racing even legal anymore? I feel like this is something they would have like shut down. I don't even know if you're allowed to race dogs anymore. Okay. Spot, Fido, Bowser. Oh, damn. Mac, Tuffy, William. We are concerned about who finishes first, second, and third. How many different first, second, third orders of finishes are possible? Ooh. Penn Center, this is some probability, right? This is permutations and, combinations and permutations. Yeah. Okay. I think the quick answer to this one is this is just 6 choose 3. Right? Is that what it is? 6 choose 3? Oh wait, but the order doesn't matter, right? So I think it's 6P3. Yeah, the order does matter. Yeah, exactly. Okay. Yeah, and so yeah, let's explain how that works. So this is actually kind of a cool one. So Equity, here's the there's one way to do it with, again, knowing what choose functions and permutation functions are. You can also do this just kind of graphically, okay? So let's think about our 6 dogs, right? We have let's have dog 1, dog 2, I don't know, dog 3, dog 4, dog 5, dog. We need another color. I'm running out of colors. Dog 6. Okay, there you go. Okay, cool. All right. So Equity, if I were to pick a dog to get into first place, right? Which dog? How many choices do I get? Like out of this, how many choices do I get to pick a dog to be in first place? 6. Good. Okay, cool. So let's say I pick the green dog. Let's just say I just picked that one, okay? So there's 6 choices, okay. Now how many choices do I have to pick a dog for second place? 5. Good. You see the pattern here, right? So then third place is 4, okay? So then you just multiply these numbers together. So it's the 6 times 5 times 4. So 6 ways to pick the first one, right? And then after that, for each dog that you picked in first place, you have 5 more choices for what you can do for second place. Yeah. You can do a tree like this if you really wanted to do this. This is like 1, 2, 3, 4, 5, 6, right? And then this would be 2, 3, 4, 5, 6, and so forth and so forth. And then this like trees out is what it does. But yeah, it's just going to be 6 times 5 times 4. So that's going to be equal to 120, which is this choice. Nice. Okay. Let's look at this one. Obi-Wan, what's going on, dude? Okay. Homer, Gomer, Plato, Euclid. Is Gomer a guy? Is this a real like philosopher of sorts. Socrates, Aristotle, Homerina, and Gamarina. This sounds like a bad time in Tijuana. Form the board of directors of the Lawyer and Poodle Admirers Club. They will choose. Dude, who the fuck is coming up with this question, dude? No person will hold more than one position. How many different outcomes are there? Okay. So we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 people into 3 positions, right? And no person can hold more than one position. Yeah. Yes, Cruz, you can always ask for help. Yes. You ate a calzone? Dude, I love calzones. I had a very mediocre pizza today at the dealership getting my car recall fixed. It was terrible. So bad. They were like, here's a coupon for letting us take care of your recall. And it was a really bad pizza. Yeah, Discord, yeah. You're good, Falcon. I got yours, Falcon. I'm talking about the other guy, Cruz. Okay. Equity, this is kind of the same, right? The 3 positions is like first, second, third place again. First, second, third, right? This is kind of the same thing. So, using kind of the same idea here, right? 654. What do you think this one's going to be? Yeah, good. 876. 8 times 7 times 6. Which I'm lazy. I can use a calculator. So 8 times 7 times 6. That's gonna get us 336. Okay, there you go. That's your answer, and you're done. Would this be a combination? No, I don't think so because if you were doing, for instance, 8 choose 3, that's the number of ways to pick groups of 3, but you don't care like what order you're picking them. I'm seeing the order as whether they're the chairperson, whether they're the secretary, or whether they're the treasurer. If I said I wanted, let's say like it was just to become like the board, okay? Not that they had individual titles. That would be 8 choose 3, okay? Or sorry, 8 yeah, 8 choose 3. That's 8 choose 3, right? Yeah. Mm-hmm. 8 choose 3 would be this. That would be 8 factorial over 5 factorial over 3 factorial. So the rule for 8, so we say like A, or I think they do N choose R. Is that what they do? NCR? It's N factorial over R factorial over N minus R factorial. That's what that would be. So if you put that in the calculator, what's that? That's, yeah, and I don't think the TI, yeah, the 84 doesn't have a button. Oh, there it is. Or actually, here's a cool thing. They actually have NCR there, which is nice. But yeah, this would be this divided by, and then it's, what is that? 5, math, fuck, where is it? Yeah, factorial, 3, factorial. That would be 56, which is probably, oh, they didn't put that as one of your answers. Oh, okay. Should have. If they wanted to screw with you, they really should have done that. NCR, all I know is NRA. Pew, pew, pew. Can you even own guns in Canada? Is that a thing? Like, you guys don't have a Bill of Rights or anything, do you? Yeah, and if you want to know, okay, so you can actually literally just do this. I think you can do this. I think you can do this. You can do 8 math, and then you can do NCR 3, and it'll do the same thing. It'll do the N choose R for you. You have to get a license though. Yeah. With bear arms, why hunting bears? Guns in Canada? I should hope so, right? What do you have, Penn Center? Curious. Probably a rifle, right? You gotta have a rifle, or you guys have pistols? I don't know. Oh, just your license. Oh, okay, yeah. Where I'm from, in
50 belt loader.
MG52 belt loader. Oh my god. You were in the military, Sensation, so you definitely like shot things. Maybe you shot people.
More like decimated entire villages from orbit, but yeah, pretty much.
Oh, okay. There you go. Okay. Cool. Decimated entire villages from orbit. The next generation of warfare. Well, these days, bro, it's someone in a DJI drone, just like taking out a tank with a, a couple $100, pilot, what do they call them? FPV drones, first person view drones, and they're just like dropping explosives on things. Yeah, it's a strange time we live in. You have a pellet rifle? I have a. Here, I'll show you guys what I have. I have a picture of my gun somewhere. Let me see. Where is it? Gun.
Is it gold?
Of course it's gold. Was that even a question, dude? What? Yeah, this is it. This is mine. It's the SPO1, CZ75 SPO1. That's a fun one. I like that.
That hammer though.
The hammer, yeah, it's a Czech gun actually, and it's one of the few pistols that's a full steel frame. So most of the Glocks and everything, they call them Tupperware guns because they're made out of like plastic and polycarb, and they don't feel as nice in the hands. Something nice about full steel. The recoil is a lot better. No, lasers are a cop out. You don't need lasers. No, it's just iron sight. It's just a flashlight on it. It's good to have a flashlight.
Give me a Walther any day.
Yeah. A Walther. Was it PPK? PP6.
PPK, yeah.
PPK, yeah.
PPK.
Yeah.
Well, it was in the 90s.
The James Bond gun. Okay. Let's see. Here we go. We got marking. What the hell is this? Okay, marking guys that favor retention of conifers. A sample of treated northern hardwood stands are selected. 10. Okay. Wow, these are. I can tell you're in an outdoorsy class because I don't know what any of these words are. Transects. Okay, are walked in each stand to count the number of groups of deer pellets found. Number of deer pellets is recorded. There we go. Okay, pellet groups. No retention. Okay. Okay, cool. Test the hypothesis that the average number of pellet groups in the retention treatment exceeds that by no more than 10. Use alpha equals 0.10. Okay. So this is a one-sided test, right? Because we're seeing that something is no more. It's not that it's just different. Yeah, you have your hypothesis. I agree with this. Okay. Well, no more than 10, though. I think it's U1 minus U2 is... is less than 10. Is that what it is? Sorry. Okay. This is U1. And the retention treatment exceeds by no more than 10. Oh, so this is U2 minus U1. U2 minus U1 has to be less than 10, is what we say. Yeah, it's one-sided, it's right-sided. Yeah, okay. Right? Test U1 is usually the first group that in retention treat exceeds that by no more than 10. Yeah, this is what I think your alternative hypothesis is. I believe. So in that case, it would be U2 is less than U1. Usually this is the first group and this is the second group, Falcon, right? Okay. All right. Oh, and you have a different number of samples in each one? Ew. Be nice if they were just matched, but I get it. They're not. Okay. Yeah, this is a difference of means t-test, right? And critical value is 0.9. Yeah, cool. Okay. So, you know what? You can actually do this in... It's actually kind of cool. You can do this on the calculator. I'm pretty sure. Let's do this. So I think you can go... Because do you get an 84 on your test? Do you get a TI 84 on your test? Or do you have to do everything by hand? Yeah, the first thing is to put all your stuff into like a matrix. Okay. No. Sorry, into a list. That's what I want. Sorry. Where is second list? Okay, there we go. But I want to edit it. Let's edit list 1. Okay, so list 1 was What is that? 102, 86, 98, 109, 92, right? Yeah, what is it you don't understand? Llama grass. You doing it in Excel here? Okay. It's probably the same thing, honestly. Do you get Excel on your test though? That I always want you to like know how to do it using the tools you get to use on the test. Because if you get to use Excel, then you can basically get to use the internet, which there's so many easier tests. There's so like they're literally like, there are things on Google that will literally do these tests for you, which are great. 1 + 1. Yeah. Asking our Discord dog. Okay, do you get this type of calculator? Do you get what I'm looking at, like an 84? Do you get to use the stat functions on a TI-84? That's usually what happens in a stats class. They at least let you use one of these. Oh, okay, cool. Then I'll just show you how to do it. It's pretty cool. So you go to stats. We're going to go to test. This is a 2-sample t-test, right? Because it's a low number of samples, first off. Like, it would be a z-test, I think, if we had more than 25 samples, but this is only t, right? So stats, or it's data, good. L1, L2. This is cool. And then we're saying that U1 is less than U2, right? No, wait, sorry, U1 is greater than U2? Wait, what's U2 is greater than U1. Yeah. Yes, this. Okay, pooled. What's the rule on whether you use pooled pooled variance assumption? What is it? Stats is all these like Okay. Pool variances can only be used when we know that 2 or more populations have the same variance. I don't think we can assume they have the same variance, right? Yeah, Z samples for over 30. Yeah, cool. Thanks, PCT, for the follow. Appreciate it. Okay. Yeah, I don't think we're gonna pool it. Yeah. All right, so let's just calculate it. See what happens. Okay. Cool. All right. So we get a T of minus 1.63. And then what's the average difference? Do they give us what the average? That's a big difference. Wow. U1 is less than U2, yeah. Yeah, what's up? What do you want to shout out for? What equation? Which one? Which one? Yeah, okay. So this is a very... One sec. Yeah, okay. Yeah, sorry, I was wrong here. You added something to Discord that might help? Let me see. Yeah, okay, cool. And that's what we did. Use the... Yeah. 2-sample t-test with an unpooled, and that's what we did. Okay. We got T's... So there, we got P was equal to 0.07, though. Which is okay, right? 0.07 is less than 0.1. So... This would be, we would reject H naught. Now, the thing that kind of bugs me though is that they said that the treatment, okay. Oh, by more than 10. Okay. Sorry, I read this as like no more than 10. No, it exceeds it by more than 10. Uh-huh. What show? The 64 grass of all time. Yes. Yes, good. You're fine. Yes, shout out Llama Grass 64. There you go. Is that what you want? You can have it. It's fine. Yeah, I wonder about this part. The more than 10 part. I guess you compare this to it being, yeah, I mean, usually we don't say that it has to be by more than a certain amount. So I would say that, I mean, because the null hypothesis is that, oh, you know what the null hypothesis? It's not that they're equal, actually. And this is weird. Yeah. So you have this, sorry, with okay, sorry, one-sided t-tests, yeah, where was it? It's this. What I want to say? Hypothesis, null, alternative. Oh, okay. No, you're right. The null hypothesis is always that it's just equal to it. Okay. No. This is it. This is what I was thinking about. Okay, here we go. Yeah, this is what I'm thinking. Yeah, so this is the tricky thing with one-sided tests, Falcon. The null hypothesis is not that it's equal to, it's the other realm of possibilities. So if I'm saying that U1 is greater than U2, and really it's U2 is greater than U1 plus 10. Then we say the alternative the null hypothesis is that U1 plus 10 is greater than or equal to U2. Yeah, exactly. It's this. Yeah, you have to do these. Yeah, we play Fortnite on Sundays, yeah. No Fortnite. I used to do Fortnite on school days, but then I ran out of time. Yeah. Yeah, I'm not quite what to do with the no more than 10. That kind of bugs me. But I would just say reject it. Whatever. But this is Sunday? Dude, what? Bro, what planet llama do you live on, dog? Anyways, okay. Hopefully that helps you out a little bit. That's kind of a weird one, though. But, yeah. Good job on it.
No more ketamine for that man.
No more ketamine for that guy. Bro, I love that one of the Postman Pat and his black and white. The Postman Pat one. It's so fucking
Postman
funny.
Pat and Jess are on cat.
God damn it, dude. And yeah, Falcon. Wait, and that's your question for the week. So there you go. You get credit for that. Nice, dude. Good job. All right, let's see. I gotta go teach another student in like 20 minutes. So let's see. Oh, you need help finding D? What is D?
D's
What?
nuts.
Yeah, D's nuts. Yeah. Wait, what was D? Is D the difference? Sorry, wait, what is? Sorry, you talking about this? Ah, what is that? Sorry, what's D in a T? Is that the difference? D in a 2-sample t-test. Oh, Cohen's D. Interesting. The effect size. It is calculated as the difference between the means of each group, all divided by the pooled standard deviation. Okay. Okay, so for this one. Okay. That's interesting that they ask you for that, because we usually don't do that. So, D is equal to, in this case, it's going to be, what is that? These two means. So it's going to be 125.57 minus the 97.4. And then we're going to divide that by, that's at the pooled standard deviation, but I guess you can do the unpooled standard deviation, which, oh man, they don't put that here, do they? Oh, that's such a pain in the ass. They don't show that. Sample t-test. Let's just assume it's pooled. Calculate. There you go. And this is the pooled standard deviation, which is 34.72. So this is what D ends up being. This is going to be my job. Yeah, this is Cohen's D's. Yikes. Dude. Cohen's D's nuts. I think Cohen actually means like priest in like Hebrew or something. Yeah, it means priest. Yeah, I know that's because I have a couple friends with the last name Cohen. Yeah. Yeah. Cool.
Ollie G.
Ollie G. All right. Hopefully that helps out. I think. Okay, we got no more questions, and yeah, I'm running out of time because I gotta go I gotta go teach another student to go pay my rent. So, anyways, okay, cool. Thank you everyone for coming to Office Hours. Had a really fun time answering all your questions today. We learned a lot. If you just found us on Twitch, please join our Discord. There's a link here. I'll put it just Discord. And then that's where, yes, Llama, if you want to know where we play games, go to the Discord, and we do those on the weekend, and I give out prizes all the time. I bought someone $20 of Robux, like, the other day. But yeah, if you want to help with math and science, our next help session is going to be tomorrow. That starts an hour later than usual. That's going to be at 5 p.m. Pacific, 7 p.m. Central, 8 p.m. Eastern. Same place here on Twitch. Again, if you found us on Twitch, join our Discord. That's how you can find out when all of our next streams are going to be, and also how you can earn prizes for getting help with your homework. That's a big thing of what we do here. We're a 501c3 nonprofit, and we give out gift cards, video games, consoles, all sorts of stuff just for you getting help with your homework in our Discord. That's how we do it. Yeah. Monkey wants more bond coins. You want more stream? Yeah, I know. It's okay. Okay, cool. All right, let me see. I'm going to raid someone else. Because, yeah, if you're participating in our tournament, you get MT coins for raiding channels. Who else is on? Oh, we got Science. We're going to go raid the Science people again. Let's see what they're doing. They said their stream is starting soon, so whatever. We'll start the raid. So, yeah, cool. If you want to keep hanging out, learn some more science stuff, Science streams is pretty cool. They do some dope stuff. They're starting in 5 minutes. But go raid, say hi to them. And I will see you guys tomorrow. Enjoy the rest of your Tuesday. And another big thank you to all our top subscribers, server Discord boosters, and donations. Love all you guys. Cool. All right. I will see you guys tomorrow. Peace out.